We are now recording. So again, if you have your camera on and your microphone on, you are consenting to the fact that your face and voice will be on YouTube. If you have any questions and don't want to use your microphone, please put them in the chat and I will interrupt Phil and Michael as necessary to ask the question. So our topic of the day is Introduction to Traefik, the container edge router and reverse proxy. And with us today, we have Irwin and Phil Fenstermacher. Michael works at Virginia Tech and is a Docker captain. Phil works at William & Mary doing all things Docker. So I will go ahead and hand off to them. And thanks for joining us, and take it away.
Absolutely, thanks. Let me go ahead and share my screen here, just because we've got slides to help, I think, keep us on track. Hopefully they add value too. There we go. I think I did that right.
Yeah.
Perfect. Okay, just want to make sure. Thanks, John, for the intro. I'm Phil Fenstermacher. I work at William & Mary. I'm manager in our systems design and architecture team. I don't really know what that means yet, but really we work on all the DevOpsy container config management, including just some traditional sysadmin stuff that's left over because universities just have lots of weird stuff sitting around. And that'll kick it over to Michael.
Yeah, and I'm Michael Irwin. I've been full-time at Virginia Tech for about 10 years now. Rolled in right after I graduated, and I've worn a lot of different hats since I've been there. So doing software development, and I'd probably say the last 5 years have been focusing a lot in the DevOps space, the cloud engineering, cloud architecture, that kind of stuff too. So I'm helping our IT force transition to using public cloud, and been doing a lot with Docker and whatnot. And since John mentioned earlier that I'm a Docker captain, to kind of answer the question, what the heck is a Docker captain? It's somebody that's been recognized by Docker for their expertise in the field. And there's about 60 to 65 of us globally right now. And so, yeah, I don't work for Docker. I'm not paid by them or anything like that, but just kind of the recognition, and it's actually kind of fun to get to have private Slack channels with a lot of their engineers and that kind of stuff too. So there's a good chance if I don't know the answer to it, I can ping somebody that wrote the code that did it. So anyways, happy to be here, and excited to talk about Traefik today. And I guess I should also mention too, because Patricia would get after me if I didn't, actually both Phil and I are Traefik ambassadors as well too. So that's kind of how we got roped into this as well. And so it's a similar thing there. We've kind of just been recognized by Traefik for knowing stuff about Traefik. So
and just to clarify, Patricia is Patricia Dugan, who I believe correctly is the community manager for Traefik, and hopefully later in our meeting she will show up and say hi and do a little more markety type stuff probably, but still worth the time.
Sure.
Yeah, so we should mention too that similar to the Docker captain arrangement, Michael and I both don't have any formal kind of affiliation with Traefik. We don't work for them. We're not paid for them. We just kind of use it in our jobs. And because we started using it and sharing what we were doing with it, they kind of like, hey, here's a t-shirt kind of deal, and help, we'll put you on the list when somebody wants a speaker. So here we are. Just to give a little bit of background, I guess, on why, what Traefik, kind of why we need it, kind of do a quick kind of problem sort of thing. So obviously your typical web request, you make a request, something comes back. Pretty boring. We're all pretty used to it. If you're not too familiar with a reverse proxy, reverse proxy really just kind of sits in the middle, but it's more on the server side. The client talks to it. It turns around and talks to the remote server, sometimes on a different port. And then just like that, the request comes back also through the reverse proxy. Sometimes reverse proxies will do things like SSL termination, rewriting. You can do weird stuff. It's a layer 7 type thing. So you could sit there and say, oh, they're requesting this path, let's send them here versus there, or different domain names go to different backends. So Nginx is a popular reverse proxy in the traditional sense. I should have mentioned this a few minutes ago too. If anybody has questions, please just interrupt us. And one, it's a small group. Two, we don't really know what everybody's background is. We're new to the group, so please just interrupt whatever if you have questions. And then kind of once we're through this, I'm sure we're going to poll because we want to hear experience and background on a couple other things. So in this case, we would just say if you're listening on port 80, turn around and immediately pass it to this other server .local domain on a different port. Then just highlight that piece. So if you have multiple servers, you can do that too, and it can load balance between them. This starts to get into what you would see in like a traditional, like an F5 and A10, some enterprise level load balancer, application delivery controller, I think is one of the marketing buzzwords for it now. This thing. So in a case like that, you may just say on port 80, pass it to these two services. We can do a quick demo on this too. I've got one set up locally. So if I just say localhost, so this is going to go to my laptop. We can see the host name up here at the top of the server. And if I ask it again, we should see that I got the Raspberry Pi that I've also got running here at home. And then you just run it a whole bunch of times and it should effectively round robin and just kind of bounce back and forth in a fairly boring way. So to configure that, like I've shown the example, I've got to have each server kind of configured up in this little upstream section here. And it's all manual config at this point. They've got fancy service discovery things out there you can use to try and automate some of it. But this is kind of the full traditional sense without any kind of assumptions getting made. Let me see. There we go. So in a container world, I know this is probably a good place to stop for questions too, or stop for questions and kind of find out. Not sure how to poll the audience. Maybe the raise hand feature in Zoom works. I'm not sure. Does anybody what's kind of the experience in the room with containers, or if somebody just wants to speak up too? They can kind of help us. I don't want to recap things everybody's heard 100 times. Are people running them? Michael, maybe you have a better idea of how to ask the question.
I think you'll find the group here is pretty wide from hobbyists to professionals. So I don't know that you can go too low or too high, but probably want to keep it basic unless Mr. Kennedy has different opinions there. Yeah,
no, and also we just last 2 months ago, our Peter Larson did an intro to containers, and then last month did an intro to OpenShift. So this is our follow-on from that.
Okay.
And then I've got two questions. One, what is the syntax / language for the config? And I'll let you answer that one.
Sure.
First.
So I'm assuming they're asking about the
Nginx config, yeah.
Yeah, the Nginx config. So the example I'm using for the proxy on here is just an Nginx configuration file. I don't know if they have a name for their configuration syntax or not. In this case, I'm just picking on Nginx because that's really popular as a reverse proxy, kind of in the traditional sense. And even in the container world, you find it pop up fairly often. So.
Okay. And then the second question based on this, and I think I know the answer, but I'll let you officially answer it. The / after location, what is that represent?
Yeah, so what that's basically saying is at the root of my application, if I make a web request to http://localhost, there's kind of that implicit / after that request. So it's saying / and then anything beyond that. What I'll actually talk about in just a minute, we've got a slide where we kind of show what other things we might put in that kind of situation.
Awesome. Those are the only questions so far.
Okay. Yeah, please continue to interrupt with questions. I want to make this useful, and I think we've got a small enough group. It's pretty reasonable just to handle them all as we go. So in a container world, if you're talking about a particular host or certain clustering systems, even you can only publish each port one time. So we'll just pick on port 80, the obvious for web things. So it can only get published once. So if you have an application, in this case, I'm just going to use this who am I example that we used. It can only, since we can only publish it once from a set of containers, it gets really hard to publish multiple applications, which is kind of why we use reverse proxies for a lot of these things. We maybe have one IP address or one kind of load balancer front end type thing. And then based on what the contents of the request, which host name you're requesting, are you requesting, in my case, maybe I want wm.edu versus, business.wm.edu for our business school. So we take those requests and then we may look at it and see, what is it you actually want? And then from there, we can decide which, what to actually send you back. But on the back end, we may not want everything on one server and in one configuration file. So in a container world, that gets a little bit tricky. So in this case, I could talk about, we've got multiple containers and now they're just load balanced across port 80. So that doesn't help us a whole lot. So now we're back in this, we need something to split the traffic up. So if we need to split it up, and this is kind of going back to your question about the multiple path things, is we can say, like, if I request / who am I, then send it to this who am I service. If I'm requesting custom app, send it to, the custom app HTTP endpoint. Similarly, we can change the server name, and we can say, if you're asking for a different host name, respond back with a completely different page entirely. That way you can have one instance. In this case, the example configuration is for Nginx. We can have this listening once and it can respond for a number of different websites, domains, different paths, and we can split all of this up across whether it's multiple. In our case, we're eventually going to get the containers, but we can also talk about multiple servers and everything else. Sometimes you'll see patterns like this, like I mentioned earlier, in kind of the more enterprise dedicated hardware environment, things like F5, A10. There's other non-commercial solutions for this other than Nginx, things like HA proxy. Apache can do this as well. And then a lot of times people will sprinkle other things in, like maybe authentication on / who am I, but not on custom app. So at this point, once you've got a config file, you can just extend it as much as you might need to do. So in a container world, what things end up looking like is we have people talk to, since we can only publish port 80 once, they talk directly to our proxy server. And the proxy turns around and says, oh, you want who am I or custom app. And we route the requests accordingly because this proxy layer handles all of our web requests. And it might even do SSL termination if you want to have encrypted traffic for everything. And then once you're inside your container world, you can either continue to do encrypted traffic, or you could consider it a trusted network. Approaches vary. And in the container world, it goes really wild, really quick. So we're not going to get into that stuff today. We're just going to kind of focus on this proxy piece and what it might need to do. So one thing, immediate thing that I know a lot of us that work in the IT space want to do is, well, there's one of everything here, which is bad because things inevitably break. We want to do maintenance. So we can add more of them and we can just have it proxy and load balance across the different, who am I services or custom app. And a reverse proxy sometimes can do smart things too, like if you need persistent sessions. Persistent sessions being in the sense that when I log into, let's say, custom app, and I'm on this top one, we'll call it the instance A. When I first log in, instance A now kind of knows who I am. We've established this session token thing that will pass around back and forth to make it work a little better. I think Michael's going to talk a little bit more about that here just a little bit. But I identify myself to custom app and it knows who I am. But if my traffic goes to custom app B, it may not know who I am and it would forget about things. So that proxy can add some other value things like persist. Hey, when Phil gets here, make sure he goes to A because that's the one that actually knows who he is and can log him in. So similar to how we had the configuration for the Nginx proxy, where we would say, okay, if you want who am I, then talk to my Raspberry Pi and my laptop with the other thing running. Every container gets an IP address. So I'm not going to spend too much time on this because we're more setting up the problem rather than this isn't a practical solution. if you go in and you inspect a container in Docker, you run these commands, you'll get an IP address. We can turn around and plug that into the Nginx config. You can do everything, and you can build this kind of thing that looks almost like this, where we want to have separate, servers for different, separate containers running each of our different components, and we're going to spread it all out through one central reverse proxy, and we're going to encrypt it on 443 in this case. And I just realized that line coming out of the little cloud client, I don't think it's straight. It's going to bug me now. So far we've kind of talked about this in the abstract. We haven't talked about particular servers. So in this case, let's say we have 3 servers and these things are running there. We also want to make this highly available. Like we said, there's failover, at least at the app level. So if you think about what we had to do to configure this Nginx container, we're having to do this Docker inspect command and grab IP addresses of all of these different components. And then we've got to go and plug the configurations in and keep track of them when a container restarts, because the IP address will probably change. And then we want to make it highly available. So we're going to add a whole bunch of lines everywhere, and it gets really complicated really quickly, and a giant pain to maintain. And then just to make it extra fun and paint the whole picture, we're also going to usually run all of this behind some kind of load balancer, because now we have multiple pieces of hardware we need to fail over between. This can be, an F5, an elastic load balancer if you're running in Amazon, anything kind of like that will work. So clearly this looks like a giant pain and is really hard to maintain, and nobody actually wants to do this. And that's so we kind of said, well, what if the proxy could actually talk to Docker directly, or Kubernetes, or a whole bunch of other things, and figure out where does stuff run? And that's exactly what Traefik is designed to solve. It will dynamically look the stuff up and kind of go from there. So I think now is probably a good stopping point to see if there's any questions. And from here on, we're going to go and explain Traefik in depth. This is just kind of just like I said, setting up the why Traefik. Why do we need yet another tool when we already have reverse proxies out there?
Yeah, and one thing I'll just add to, if go back 2 slides to your picture of the cluster. Yeah, this is hard to set up just once, but also recognize it in a lot of containerized environments, these containers are coming and going all the time. And that's kind of the whole point of containers and the DevOps movement is to be able to build apps, respond to user needs as quickly as possible, all this kind of stuff, and expedite the ability to deliver value for your organization. And so, yeah, if custom app, for example, is being replaced, maybe every couple hours, or even every couple days, where something's got to be sitting there watching that and updating config and all that kind of stuff. And depending on how large the cluster is, that starts to get really complicated really quickly. And so, yeah, especially in these containerized clustered environments, things are constantly changing, constantly adapting, and so keeping up can be quite difficult there.
We have a question. If there's an SSL cert on the reverse proxy that terminates on the reverse proxy, is the connection encrypted to the client container? So from in this case,
you're thinking kind of like this arrow right here, or this arrow. Mouse.
I'm gonna assume it is that arrow.
Mm-hmm.
The person who asked the question can update that in the chat if I'm wrong.
So that's kind of one of those, it can go either way kind of scenarios. In the example that I've put here, it's not encrypted, but it can be. Now, encrypting traffic, there's a lot of different ways to encrypt traffic. Obviously, with everything, there's a lot of different ways, but within a container environment, there's some additional tooling that's available to us, and I don't want to go too deep into the weeds here. But there's even more options that traditionally in a not containerized environment would be really difficult and a pain to set up for essentially the exact same reasons that we've outlined here with these reverse proxies and everything changing, like Michael said, where it's just too much to keep up with. So like I said, for the simplicity here, we've done this. The quick options are you can just encrypt the entire network. You can set up like, I think it's Docker's got some methods of doing IPsec. There's service meshes with mutual SSL authentication. There's a whole bunch of different options. Like I said, it's kind of out of the scope of this, but to answer the question straight up, in this case, no, but they can be.
Yeah, and I'll add to that too. So like John said at the beginning here, the end users, when they actually access the app, a lot of times in architectures like this, the SSL termination might actually be happening even further upstream. So at the ELB, the F5, a lot of times it may be even happening outside of the cluster. And so then it coming into the cluster, even Nginx 443 may not be the final cert, that end users are terminating with. It could just be a in-cluster certificate that the ELBs, the F5s are trusting. And then from, in this case, Nginx to the who am I, that again, like Phil said, it could be encrypted. There's nothing stopping you from doing that. Just, of course, your containers themselves would have to be communicating over encrypted channels, have HTTPS endpoints or, whatever encrypted means for the app you're running. And so they would have to have those private keys or whatnot. So there's nothing preventing that from happening. Just the end users aren't seeing it. So a lot of times it comes down to what are the requirements for your application, for your network, for the architecture. And so actually a lot of times people will say, well, internal to the network, I'll just use IPsec, but not go anything beyond that. And because I'm already internal to the network at that point. And so who cares kind of thing, unless the application requires me to have full end-to-end at as many layers as possible kind of thing.
And quite oftentimes those internal certificates are self-signed.
Yeah.
Just so you don't have self-sign exposed.
Yep. And that's exactly how we run this at William & Mary. In fact, we replace Nginx here with Traefik. We have a load balancer sitting in front and the public termination is there. And then internally we use some self-signed stuff.
And with this particular slide, the indication of it is nothing is encrypt that goes to or from port 80 in those 4 instances.
Exactly. And I think that's where I know Michael kind of said that you might just use IPsec or something. And then by using IPsec for a lot of those different parts, you're encrypting the traffic from a machine, in this case, the red box to another red box. Because of how containers work, if you're on the machine, it's not quite like I guess even on a VM, you'd have the same issue. Once somebody's on the physical machine, you've got bigger concerns. So we traditionally, as long as we can move traffic between machines in an encrypted area, or in our case, we have still a physical data center, or I should say one of our container clusters is in a physical data center. The other one is in the cloud. But the physical data center, when they're all plugged into the same switch, the top of a row in a secured room. So we can make some reasonable assumptions about traffic between the machines as well. So it kind of depends on the environment of what fits. You can see there's another question about idle keep alive timeouts. You can. So I don't want to get too into the depths of traffic quite yet. We'll dive into the config here in a minute, but reverse proxies typically let you configure really whatever you want on a per kind of back-end basis. And you can support different things like maybe you need to use WebSockets or something where there's another kind of HTTP upgrade kind of protocol type thing going on. And I will say too, go ahead.
I was just going to say that full question was, can you set different idle / keep alive timeouts for each web context? That way somebody listening later will know.
Thank you. And I will say too, just because I'm in the middle of it right now, we have an F5 load balancer at William & Mary, and so we're in the middle of kind of replacing it and porting all of that configuration over. Having to manually configure your reverse proxies, in this case, this example, we were using Nginx. Think of every time a container changes, like you replaced a new server with a new IP address and you've got to go in and reconfigure it. And after living in the container world for a while and now having to go back and do some of that front-ending maintenance again, I realized I was very happy to leave the manual configuration behind. So I'm going to stop sharing my screen here and I'm going to hand it over to Michael to kind of pick up the next section for us.
Okay. And so now we're going to start talking kind of traffic. And before we get too much directly into traffic, I'm going to talk a little bit about just Docker and may go a little bit deeper than what you guys might have covered in previous discussions, because it provides a good foundation of some of the things that we need to know in order to understand the value that we're getting from traffic and how it works, but then also how that extends to maybe other situations that we may be running applications. So I'm going to start off with a little bit of marketing blurb here. And this was actually from the Traefik website, I don't know, a while ago. And so this exact quote isn't on the site anymore, but I liked it enough that I've continued using it. And so I'm going to read it first. So Traefik is a modern HTTP reverse proxy and load balancer that makes deploying microservices easy. Traefik integrates with your existing infrastructure components and configures itself automatically and dynamically. Pointing traffic at your orchestrator should be the only configuration step you need. Okay. Now I know that there's like a lot of, this is the one solution to rule them all kind of thing. But actually, as we get into this, you'll see that it is as simple as it says here. One of the things I do want to just mention is that it says makes deploying microservices easy. Originally, when Traefik did start, it was very focused towards the microservice-based environments where you may be, breaking your app into lots of pieces and that kind of stuff. But I'll extend that and say that it's not just for microservices. It can just be for any apps in general. And so we'll see examples of that as we move forward here. So again, Traefik, again, like Phil was just talking about, is a reverse proxy that kind of replaces the Nginx layer and theoretically makes things easy. So the way that it does this is, can everybody see the mouse pointer? Is it showing up? Or do I need to use the laser pointer?
Yes. No,
Okay.
we can see
Okay,
it.
cool. All right. Good. So as requests come in from the internet or from wherever and lands at the reverse proxy, it's going to send them off to the right place doing load balancing, and it can also do some advanced things like canary and mirroring, which maybe I'll define those real quick, but we're not going to do examples of this. So canary based deployments it's a reference back to the canary in the coal mine, where in the coal mines, as methane levels would rise, obviously they would become dangerous to, and even probably carbon monoxide, just poisonous gases in general. They would become poisonous to the miners. And so a way to detect that is they put a canary in a cage in the coal mine, and canaries would be susceptible to those poisonous gases much earlier than people. And so if you see a canary dead in the cage, you need to get out of there because obviously there's dangerous gases there. And so it's probably a pretty gruesome thing, and PETA might get after us for that, but whatever. But this idea has kind of held on, in which if I'm going to deploy an update to my application in a containerized environment, I can deploy a canary and maybe send a very small amount of traffic to it, maybe 5% of my user base to the canary, and make sure that the app is still working. And if it's working, then I've got a good assurances that as I increase that percentage, that capacity, then I know that the app is going to be working. And so again, the kind of this canary testing has become quite popular, and Traefik can help support that. And mirroring is something very similar. Instead of sending just maybe 5% of traffic, what it does is it actually sends all of the requests to the original service, but then mirrors it to the next one. And so then you can check metrics and see, are my response times similar? Are my memory utilization? So it's sending the request to the original service as well as a secondary service. And so you can do some pretty neat stuff there too. Send traffic from Canada to the Canary. Yeah. And so the blue boxes down here are the routing mechanisms, similar to what we just saw with Nginx. So it's just forwarding requests as expected. But what's unique about Traefik are the top pieces here, especially the purple box here, the auto discovery. So what Traefik does is, instead of relying on a config file that maybe is getting updated by an external script or something like that, Traefik has built-in mechanisms to observe the environment around it and update its own config based on what it sees and hears from the environment around it. And what this allows Traefik to be is basically an event-driven system. So as events are happening in various, in this case, orchestration frameworks, and it mentions Kubernetes and Swarm, there are lots of other providers that it plugs into. But as it hears of changes going on in these orchestration frameworks, it says, well, hey, here's a new container that's spun up. Let me go ahead and update my own config and respond to it and be able to start sending traffic to it. So again, it becomes very event driven rather than now if somebody's got to update a config file or a script has to update that config file and then Nginx loads that additional config. Nginx for the most part is a very dumb system in the sense that it doesn't know how to update itself, and you have to use other tools to update the config. While Traefik, on the other hand, is a very smart and event-driven system and is responding to what's going on around it. Okay, so that's one of the really, really big differences here. It allows it to be very dynamic and adjust to what's going on. Observability and tooling, we're not going to talk too much about. We may be able to drop some hints of it towards the end, but it's got a lot of really nice observability endpoints where it exposes metrics and tracing and that kind of stuff to see what's going on or what endpoints are going slow, all that kind of stuff. All right, so let's talk about Docker and how Traefik integrates with Docker. And we'll start with this as the first example here, because it kind of builds on what you've talked about over the last couple sessions. And we'll then continue to give you the fire hose treatment and give you more. So when you run Docker on your local machine or on a server, Docker at the end of the day is running a Docker daemon in which that daemon is starting containers and managing volumes and basically everything. But the way that it works is that the Docker daemon actually exposes a REST API around it. Okay, and this REST API, in fact, maybe I'll just open it up here. The REST API has tons, and they've got it all documented. So if I wanted to do anything with a container, here are all the endpoints for a container: to list containers, create containers, inspect, export, stop, kill, rename, pause, attach to network, all these different things. And that's just the container spot. And networks and volumes, there's lots of different endpoints for all the different things. So if I wanted to list a container, for example, I can make a get to /container/JSON, and here's the structure, here's all the fields. There's a ton of stuff here. Okay. But Docker recognized, cool, we've got this API here, but we don't expect most people to interact with the API directly. That's kind of lame. But it does allow for a lot of extensibility. So what they did is they bundled in the Docker CLI. And so when I do a Docker run, at the end of the day, the Docker run is really just an HTTP REST client that's invoking commands against that API. Okay. And that API then is behind that API is a server, and that's what's actually starting containers or providing the metadata, all that kind of stuff. Okay. And again, this allows lots of extensibility. So the Docker CLI is a client, the Docker Compose tooling, that's just another tool that interacts with that same REST API. The Docker socket is how that API is exposed locally on a machine. If you're not familiar with Unix sockets, it's basically a way to do network type communications, but still local on the machine. So rather than opening up a port that somebody can access from using an IP address, it's a file-based mechanism. And in fact, let's do an example here. I'll zoom in a little bit. Okay, I'm going to do a curl against a Unix socket at var run docker.sock, and I'm going to query the endpoint containers / or sorry. Sounds like I'm getting some feedback too.
Yeah, Michael, I think you might just be sharing your web browser.
Am I really? I am. Okay. There we go.
There we go.
Okay. So now I'll do a curl Unix socket, and I'm going to specify Unix socket and the Docker socket, and I'm going to the host name here doesn't matter, but I'm going to hit the container/JSON endpoint. And right now I don't have anything running, so maybe let's just run Nginx in the background. Let that start up. And now when I've already got that started. So now I've got two started. That's all right. And now when I run this, I get this huge JSON blurb, which if I pipe it to JQ, now I can see a bunch of information about the containers. Okay. So quite a bit there. And I do see a note in chat, the introduction to containers, we use the daemonless podman that doesn't require socket and root access. So yeah, there's lots of different ways to run containers. And yeah, podman does it a little bit differently. And so if you're using the Docker or Docker engine, this is how it would work as well. So again, this API endpoint gives me a lot of access to the various, the engine and everything else that's going on underneath. All right.
And Peter, I will jump in too real quick. The socket, you can kind of treat it like a file in Linux, which is why if you're on a Linux machine and you add a user to the Docker group, by default, the Docker group has write access to that socket. So while the Docker daemon itself is still running, doing root things in the background, the Docker command line itself doesn't necessarily have to use root. So it is kind of a weird way, though I put the caveat is if somebody is in the Docker group, they can effectively become root on your box just because of they could share, whatever directory they wanted into a container running as root. So rootless is a whole weird thing in the container world, but there are ways around how you want to control access to that file or the socket file.
Yep, and that's a great point. And so I think Phil, Phil, are you echoing? Yeah, I think I'm hearing my mic back through you.
Yeah, no, it's still echoing. Now
I'll keep my hardware thing muted then.
Nope, it is.
Test 2, 3. Okay, I'm not hearing it now.
Yeah, that's good.
Okay, interesting. Okay, and so yeah, this last bullet point: be careful with who or what has access to the Docker socket. And so yeah, that's exactly one of the things to be careful of. Even if I don't have root on the machine, if I'm in the Docker group, I have access to that socket, and so I can launch containers, and I could theoretically launch a container that mounts the root of the file system into the container. And if I run as root inside that container, I theoretically have done a privilege escalation. So you do have to be a little careful of who has access to that Docker socket. And yeah, that's exactly what Peter just said. I can create an escalated container and gain root access on any Docker daemon box. And there are ways to work around that. And we won't go too much in the sidebar, but there's a capability called user namespaces, in which if I run a container, I can be, quote, root inside the container, but root inside the container is not root on the host. And so there could be a difference between that. And so the user namespacing basically creates a mapping that UID 1 inside the container is UID 1426 or whatever on the host. So there are ways to keep that safe too. Yep. Yeah, and so yeah, Podman does that as well. All right. So listening to Docker events, one of those endpoints lets us listen to events that are going on in the system. And so as things happen, as containers start and stop and die, or whatever, it's publishing events. And the screenshot down here, I'm doing a Docker events, and I'm just saying I want to hear the container events. So I'm not hearing like networks and volumes and all the other kinds of things. And just starting and killing a container, I see all these different events. So there's a create, there's an attach, there's a start, there's a resize, there's a die, there's a destroy. There's all these different events that are going on. And what this allows is the ability for other tools to listen to those events and respond to what's going on in the system. And that's what helps this become an event-driven system. And again, this is just Docker's way of doing things, but Kubernetes has its own API system, and there's basically every container orchestration system that you can use to run containers support this event-driven mechanism, because at the end of the day, that's what they're doing internally as well. If I want to ensure that I've got 3 replicas of an application running, and if I hear a container die, if I hear that event, the internal orchestration framework is saying, hey, I wanted 3 of these, but one of them just died. Let me spin another one back up. So they're event-driven themselves internally. And by exposing those events, it allows other tooling to do things on top of that as well. Okay. So starting Traefik. What we're going to do here is I'm going to start Traefik, and I'm going to use Traefik 2.4, which is, I think 2.5 just dropped, but that's okay. Not much of a difference for what we're doing today. And what we're going to do is we're going to specify and tell Traefik, hey, Traefik, you've got lots of different mechanisms to be able to discover containers and what backends. But what we're going to do is we're going to use the Docker provider. And so what that's going to tell Traefik is it's going to start listening to the Docker socket and the events that come along that socket. And as containers come and go, great, it'll update itself. I'm also going to add a --api.insecure, and I'm just going to do that for local testing and demonstration purposes right now. What that does is it launches a dashboard, and that dashboard will allow me to see its configuration just kind of in a GUI environment in the browser. And that dashboard's available at port 8080. So I'm going to expose port 80 so that web services, that it will act as a reverse proxy, and then 8080 so that I can access the dashboard. I'm going to mount the Docker socket in so it can listen to the events and go from there. The reason that there's a .insecure at the end of this is because the Traefik API, by default anyways, exposes the ability to make changes to the internal configuration of Traefik. So if you want to have an external tool and kind of push updates into Traefik, you can certainly do that. And so by default, that's not protected. And you can add additional middleware and that kind of stuff, which we'll talk about a little bit later. But again, just for local testing, local demonstration, I'm just going to let it run. Okay. And so we'll start this up here in just a second. I'm going to show one more slide, and then we'll actually start things up here. So once Traefik is running, there we go. The question is, how do we know what to route to it? Okay. And this kind of goes to the question that just came up. How does Traefik differentiate between internal and external services or containers? What sorts of things do we want to expose versus the things we don't want to expose? And the way that it does this is it uses labels on the containers. So when I launch a container, I can attach labels to the container, and labels are really just key value metadata. For the most part, it's not going to change how a container runs, but it can be used to, again, attach additional metadata. So if I wanted to do a Docker PS, or for example, and I want to say, I want to find all the containers that have this label on it or whatever, I can do filters that way. Maybe I put labels on this group of containers to say they're in a logical app unit. And so I can say, I want to query all of app A versus app B or whatever. And so you can do things like that. But labels can also be used for extensibility. And that's exactly what Traefik's doing here. So I can add labels to a container. In this case, traffic.http.routers. A service name or an app name .rule, and what that will do is specify the rule of when should incoming request be sent to this container. Okay, and we can look at the rules here in just a minute, and I've got a link here. We'll share the slides and that kind of stuff too. So and you can make some pretty sophisticated rules. We're going to keep it pretty simple and just do like hostname based routing, but you can do regex or path based or a combination of things. You can do some pretty sophisticated routing rules. And then from there, I can add another label to say Traefik HTTP services, service name load balancer, server.port, which I know is a long label there, and specify, hey, when Traefik is going to make that connection from Traefik to my container, what port should it use? It's going to default to port 80, but as we've seen, a lot of times people aren't using port 80, may use port 3000 or 8080 or 5000 or whatever. And so Traefik needs to know, well, what port am I going to make an HTTP request to in order to send this request to you? Kind of going back to the slide, I'm going to go back a ways here. This slide, if Nginx was sending a request to custom app, well, in this case, custom app is running on port 80, but if it were not on port 80, it would need to know, how do I send the request? What port am I connecting to? And so that's what that label is doing here. Okay. So as an example of adding some containers, and we'll do this and we'll start it up and we'll take a look at the dashboard and everything in just a second. So I've got my proxy, and then I'm starting up an app that I call Cats. It's just one of my demo apps that I use quite a bit. And what this will do is it's going to specify, I want to run this image, Mike 37 Cats version 1.0, and I'm going to attach two labels to this. The The routing rule is going to say any requests that have the host name of cats.localhost, I'm basically telling Traefik, hey, I want that to be routed to me. And then I want it to go on port 5000. Okay, when it makes the request. And just for kicks, I'm going to add another service here, Nginx, in which I'm running Nginx, and it's going to have a different host name and run it on port 80. And so what that ends up doing is it basically deploys something like this, where traffic will be exposed on port 80, and regardless of how the web traffic and the HTTP requests get to it, it's going to send the request either to the little Cats app or Nginx. And the way that it knows this is because we're using the Docker engine provider, and it's listening to the labels and everything. So enough talk. Let's actually do things. And I'm going to do one change here. Okay. So if we look at the Docker compose YAML file here, it's the same thing we were just looking at. And so let's spin this thing up here. And I'm going to use Docker compose to spin this up. Docker compose up, and then the -D is saying I want to run this in detach mode, which basically says start the containers in the background rather than keeping it as part of this or putting my shell inside of any of the containers or following logs or whatnot. So this is going to start the container. You'll see some additional warnings and that kind of stuff because I'm running also Swarm on here. You can just ignore those for right now. And this tells me, okay, it's created those containers. If I do a Docker PS, I should see those three. And I've got the Nginx. These were from earlier. I just forgot to remove them, so you can ignore those as well. That was the Docker runs that I did. So let's go back to the browser. And if I open up localhost 8080, which was the dashboard, what we'll see here is, okay, it's running on 80. That's cool. If we jump over to HTTP, we should see a couple different things here. So we see some routing rules for nginx.localhost, and we see another one for cats.localhost. It also by default puts routing rules for the container name. So if I look at this, Elastic Grider here was this Nginx one here, and so it's automatically just put one in there. I can't hit that one because I don't have obviously DNS going there, but anyways. So if I open up cats.localhost, yeah, sorry about the echoes there. What I'll see is basically what's going on here. So the entry point, if I go to Traefik on port 80, there's a router here for cats at Docker. So the at Dockers tell me this came from the Docker provider. I theoretically could run lots of different providers, but I'm just doing Docker right now. Here's the routing rule, and if the routing rule is valid, if it matches, then we'll send it off to this service. And if I go to the HTTP service and look at cats at Docker, it'll tell me that the backend server is at 192.168.32.3. And if I look at my container, Docker inspect that container ID, we'll see that on it has that address. Okay, so it's picked it up, it's seen it. And now if I go to cats.localhost, I'll see the cats app just simply displays a kind of a random GIF of some cat action or whatever. Now, so one of the things I can do is let's actually do a little update here, and I'm going to run cats 2.0. And let's launch this. And so this is going to recreate and kind of restart that container. And if I go back to the dashboard, I think I have to just refresh this page. It's still launching. Okay. And if I refresh this page, maybe it ended up just using the same IP address. But now if I refresh this, I get version 2.0, which is dogs, because dogs are better than cats. And so that's why they're version 2.0. But anyway, so it's automatically seeing the change in the environment. And even though I've got a new container that started up, it's automatically updated itself to point to the right place. Okay. And so that's certainly a way to showing off the benefits here. And now if I actually do a Docker, if I can spell it right, And if I remove the cats app, it's going to hear that. And now it gives me a 404 because that's obviously not going to work. And it removed itself from the service. It no longer has the routing rules. So it's responding to those events again, that the container went away. Let's remove the config and go from there. And just for kicks, actually, let's spin it back up. And I'll hit the Nginx service to you real quick. All right. And so we see cats.localhost show up there. It's now responding. And if I go to nginx.localhost, I get the welcome to Nginx page, just the landing page. Cool. So again, Traefik is sitting on port 80 and then is based on the routing rules, figuring out where do I go. Now, the other containers, I can launch other containers like databases or all that kind of stuff. And if I don't put the labels on them, then there's no routing config that's put in there, and it's not going to try to connect to those containers. You can't, that they basically stay internal services and can't be accessed from the outside. So again, you have full control over the labels, and there's a lot of other labels. The ones that we've got specified here are the typical ones that you see. What routing rule do I need and what port do I send to? But there's a whole selection of lots of other things that lets you configure a lot of other aspects of how the routing works, and like timeouts and weights and all this kind of stuff. There's a lot of really cool stuff that you can do with that. So maybe with that, maybe I'll mention this real quick too. I don't know if you guys have talked about Swarm or not. I know that Swarm doesn't get a lot of talk, but I at least just wanted to mention it because for some people, it might actually be a lot easier to run a small little Swarm cluster at home rather than like a full Kubernetes type thing. If you're not familiar with Swarm, it's basically a container orchestration framework that's built into the Docker engine and will let you run containers. And you can theoretically scale it out to multiple nodes and all that kind of stuff. But a lot of times people will even run a Swarm cluster of one. And the advantage that comes along with it is that you can simply declare your state and then the orchestration framework makes it a reality. So if I say I want one instance of this container running, if that container dies for whatever reason, well, the orchestration framework will say, cool, let me spin it back up. And that's some of the advantage of using an orchestration framework rather than just running a Docker run where there's nothing making sure that it's up and running all the time. And so in this case, the scaling out the Swarm, all I have to do is I change the provider. So instead of just providers.docker, now I'm telling it to run in Swarm mode so that it watches different types of events and different metadata. So Peter asks, is that what Docker's restart always does? Restart always has some interesting failure modes, and so yes, it can, if it dies, can restart it, but it has no way to do like exponential back off or that kind of stuff if your app can never start. But then also one of the other advantages that comes along with orchestration is if I've got version 1 of my app and I want to deploy version 2 of it, it can do like rolling updates and that kind of stuff where you can't really replicate that with the restart always, and at least without manual process as well. So restart always can make sure that your app is always up and running, but it does have some interesting kind of failure modes in it as well. And so jumping back here, the only differences that we've got going on here, if anybody wants to run Traefik on Swarm, is right now I'm telling Traefik needs to run on a manager node so that the Docker socket has full access to the cluster and can see the events regardless of where the containers are running in the cluster. And one of the other things I'll just mention here too, this is a pretty common pattern that if you're running in clustered environments or you're running lots of different applications in a cluster, a lot of times the proxy will be defined in one stack and deployed by itself, unlike here where the proxy was deployed with the other services. So you may deploy the proxy and then say, all right, now I'm going to deploy the app in a separate YAML document, or all your different apps are in separate YAML documents. In order for them to communicate with each other, they need to be on the same network. So a lot of times the proxy stack, as Swarm calls it, will define a network, and then all of the other services will have to attach to that network so they can communicate with each other. And an example looks like this, which then I launch an app, and when I launch it, I specify that the default network is that proxy network. And so then there's an actual network path between the proxy and the other containers. So that's what this ends up looking like. So this is a 3-node cluster here, in which now Traefik can hear events from the Docker engine, but then send it off to, in this case, an engine X. I've got 3 replicas, and they're spread across 2 other nodes. And so regardless of the node, since they're all part of the same cluster, they can communicate with each other, and they're on the same network. So in this case, Peter just asked, so every node needs a reverse proxy? No. What ends up happening is the request will come to Traefik, which is exposed on port 80. And again, I don't want to make this a Swarm workshop or anything, but when in Swarm, if I expose port 80, it actually exposes port 80 on every node in the cluster. And so even if a request comes to this worker node on port 80, there's IP tables rules that will then send the request back to Traefik over here, which then, yes, may end up round tripping it back. And so it's happening in kernel level redirects and everything. And the Docker engine and the Swarm cluster and everything keeps track of all those rules and everything. So an external load balancer can simply say, hey, just throw this to port 80 on any node in the cluster. And regardless of which node the request actually lands on, Traefik will then end up making sure it gets sent at the right place. So again, I don't want to, we could probably spend an entire other session. Maybe you guys will have to have us back at some point to talk about orchestration framework and networking and all that kind of stuff. But yeah, these orchestration frameworks that regardless of where the app is actually running, the external systems don't have to know about it, and the request will still get to where it needs to go. Sure, there may be some optimizations to say, hey, I know Traefik is only going to run on manager nodes, and so I'm only going to send the request to manager node. All right, so follow up. Not sure if I understood. If you have 5 containers on each node, how does Traefik route to specific containers on each node if it only exists on one? So what's happening is Traefik is, again, listening to the Docker engine, and it knows where all of the different services, all the different containers are scheduled. And the networks that the clustered environment uses span across the nodes. They're using VXLAN or a variety of different networks. And so it knows, okay, Nginx 1 has this IP address, Nginx 2 has this IP address, Nginx 3 has this IP address. And so really Traefik is just saying, hey, I'm going to send it to 192.168.3.7, whatever. Traefik doesn't really know nor care what node it's on. It just needs to know the IP address, and then the IP, all the IP routing rules will make sure it gets to the right place. And so yeah, the VXLAN and other networking pieces make that a lot easier. And so that, again, that's part of that, what comes with the orchestration framework, to keep up all those rules and what's living where. All right, cool. So glad that helped answer that. And great questions too. Thanks for asking away. So with that, actually, I think that's a good stopping point. Any other questions or follow up here? I don't know how many people are using Swarm, so I didn't want to go too much into it, but at least just wanted to highlight. Here's another use case of Traefik listening to a different set of events, and it looks pretty similar in this case, but it's again a different set of events, and it can respond to update config, all that kind of stuff. Phil, man, they're blasting you for the echo.
I know. I'm really sorry. I'm hoping I turned on aggressive echo suppression, and then nobody could hear me when I tried talking, so I had to turn it back off.
That's all right. All right. So before we move on, any other questions so far? All right. Hearing none, I'll stop sharing and I'll pass it back over to Phil. Unless, do we want to take a 2 or 3 minute break, or are you good? I guess you just took a break since you weren't talking. How's everybody else feeling? Does anybody else need a couple minute break to get up, walk around, do something real quick?
We're mostly used to sitting here for 2 hours, so we're generally good. I mean, if you guys are looking ahead that you're ahead of schedule and you want to take a moment, that's fine too.
There's good bladder control here.
All right, hopefully we can get through this without bad echo. I've never had this problem before with echo things, so I'm, hoping it gets, not terrible. If it gets bad again, just yell at me. So to tack onto the Docker Swarm component piece, the easiest way to describe it to folks that aren't familiar with VXLAN or anything would be, think of it makes a whole bunch of nodes work like one node. If you share a port, it's shared on every node. If you do an action, generally it affects everything. It's not quite that simple, but easy way to think about it, at least from a networking standpoint. So personally, we used to use Swarm for a whole bunch of stuff. We've moved on to Kubernetes since then. So I'm going to talk a little bit about that piece of it. Sorry, I'm reading the comments on trying to fix my echo problem now. So in Kubernetes, one of the biggest differences is that it looks very similar when you look at it. Unlike in Swarm, the Traefik reverse proxy piece can run on any node. It doesn't necessarily have to be on one of the manager or controller nodes. And kind of the biggest reason I think that that's nice is it lets you be a little more flexible with whatever we might have to do. It watches resources instead of labels. There's a particular, they call an ingress object in Kubernetes. Actually, I should jump back a little bit. I know you guys did an OpenShift talk a little while back. OpenShift is essentially Kubernetes, or at least the latest versions of OpenShift are Kubernetes with some Red Hat special sauce kind of put on top of it. I think they include their ingress controller and a couple other packages and things kind of all bundled together. There's probably a better expert in here on OpenShift than I am, but so you may be familiar with some of these concepts if you guys have already done the OpenShift talk. So we're going to create these ingress objects, and ingress objects tell Traefik, hey, when someone wants to talk to, Nginx, then it needs to go to this particular service. And it's that very declarative kind of, this is how things should look. In this case, Traefik usually gets referred to as an ingress controller, purely because one, it controls ingress. And then also within the Kubernetes world, you have a lot of these objects, and then you have some controller that acts on those objects. So we'll get into this with a little bit of an example and everything here shortly. So just like Michael showed with the Docker and the Docker Swarm providers, we have to turn on the Kubernetes ingress provider. So I know Michael was using command line flags. He actually chatted about this. Personally, I use config file things for a lot of stuff, and I noticed somebody in the chat earlier mentioned that they were trying to start this up in Podman, and it looked like they were trying to pass in the toml config file. So we could do something similar here with this, where we'll just create this little config file, and I'm going to do very similar to what Michael did. I'm going to turn on the dashboard, and we're going to have it watch two different types of objects. We're going to turn on two providers at the same time. Kubernetes provides its own kind of permissioning system on the equivalent of that socket file. There's this API server that runs inside of a Kubernetes cluster, and everything that wants information about the cluster talks to this API service, regardless if you're inside the cluster, outside the cluster, anything else, just kind of this general API thing. And part of its API includes a really nice and really flexible role-based access control system. So Traefik in a Kubernetes environment or OpenShift environment or any of the kind of derivatives off of Kubernetes will run with a different service account. And that service account you give it permissions to only access the parts that you want it to see. So in our case, we're going to say, I want it to be able to access ingresses because we need to know how to get to things. You might want it to be able to access services because sometimes we're going to attach some specific configuration to to whatever, there's some annotations that we can put there for configurations at all these different levels, but maybe we don't want it to be able to access the secrets that are in our cluster. Or maybe you want it to access certain types of secrets. So there's a whole bunch of different reasons why you can do this, but service accounts in the RBAC system, as Peter pointed out, that it was one of the Red Hat add-ons back to Kubernetes back in the olden days. I guess olden in Kubernetes terms is what, 6 months ago. I know RBAC has been there much longer, but it's just such a new thing. So we can make it do and limit access to things that we want. And this is a really powerful pattern to use in a lot of different applications. We use it quite a bit in our environment, and it's quite nice. So this is what an ingress object looks like. So in the Docker environment, or in the Docker example, we were attaching labels to particular services. A lot of people joke that Kubernetes is really, we're just going to write a whole bunch of YAML to do everything, and they're not wrong. It's a lot more YAML to write than we would write in a Docker Swarm or Docker Compose style environment. But as you probably already picked up, everything is very fine grained. We have to define a lot because it's very granular and powerful with what we can do with it. So in this particular example, we're really just going to say, I'm creating an ingress. We're going to provide some metadata. We're going to name it. We're going to tell it what namespace we want it to run in. We're also going to say, we're going to annotate this, and this is kind of a predefined thing where we're going to tell it, I want it to use the ingress class of Traefik. This is important because within a Kubernetes cluster, there are other popular ingress controllers. There is an Nginx based ingress controller. If you go in the Kubernetes documentation, there's a whole pile of these things. So we personally, alone and Mary, my team, we use Traefik. One, because we came from the Docker world where I don't know that there's any others. And two, we were already familiar with it. The config just kind of ported over. We just had to swap out that provider piece. So it's something we really liked. And it's got a bunch of other just nice features that are really cool, great community, little plug for that. So then we're going to create some rules. And we're going to say, I want this to, if the request comes in on whoami.localhost, we're going to give it some paths. In this case, we'll just do the path. We're going to say it's a prefix. You can say, I want an exact match, or I want it to anything that starts with a slash. So I think this really plays in if you're doing microservices. Maybe you want them all running at one domain name, or if they're internal to the cluster, you don't need an ingress controller. Should probably clarify that statement a little bit. If ingress is only for for traffic external to the cluster ingressing into your cluster, you don't need necessarily an ingress controller for traffic from one part of your cluster to another part. So if you have microservices that are called from maybe something outside of Kubernetes, then maybe you want it to take a different path in, and say, if I'm going to /API/version1, then map to this other container over here. And if we have time later, I've got an example of that we can go through. And then we're just going to say this goes to the name, the service name, whoami, and port, and we're going to name HTTP, and that's defined elsewhere as well. Let's do a quick demo before we move on to the next piece. So what I've done is I've created a Kubernetes cluster. It's running locally. So if we go into the services, I've got some basics. We can see the dashboard is listening. I've got a little health check thing saying ping. That way, if traffic were to die for whatever reason, Kubernetes will figure it out and restart it. And then we're exporting metrics, which we'll talk about later as well. So you can see there's no whoami service in here now. So over here, I'm going to actually use a quieter keyboard. I use an old IBM Model M, so it's a little loud sometimes when I'm talking. So I'm going to say I want to look in the whoami namespace, and I want to get our ingress resources. So right now it's going to tell me there's nothing there. So just like Michael did in the Docker example, we're going to start a watch. In this case, it's a particular thing that the Kubernetes API is built in, and you can do this at an HTTP level with curl, but essentially we're going to say, just leave this open and tell me when anything changes with respect to ingresses. Over here, I've got my whoami service. I'm not going to go through this in detail because Kubernetes, as you might imagine, could be a several day talk in itself. And so then we can go through here and we're just going to say, I'm going to run this Traefik who am I service, which is just an example container that they've written, the folks at Traefik did anyway. And we're going to say ports, and this is where we name and say HTTP is container port 80. And in this case, we're going to run 2 of them. And I think this is a little bit interesting. So they're actually already running. If we go on here and I say, who am I, get the pod, and we can see that I've got 2 of these who am I services or pods up and running. So I don't have this ingress created yet. So we're going to apply the ingress. And as soon as I apply this in this other terminal window, we'll see it pop up right away. And we can see that it wants to, the host is who am I localhost, and it's listening on port 80. If we go back down to the web browser, we can see that it showed up on here twice. One of them is it's trying to do TLS. I don't have a real certificate set up. In our next section, Michael's going to run through kind of how that works. And then we'll go from there. And then I'm not defining where the non-HTTP one should listen. So we've got these entry points. So it's listening on my admin port, my metrics port, and my web port, which is the insecure HTTP port 80. So from here, we could say who am I.localhost, and then we'll get the output of this. And it just kind of gives me some information. This is more interesting to look at, actually. So because there's 2 of them and web browser weirdness, if we curl localhost, who am I.localhost, see that this is going to one container. And then if we run it again, we'll get the other container or the other pod. So if we go back to get pod, we can see that these 2 identifiers match up with the names of the pod. So it's load balancing between the 2, even though this is running entirely in my Kubernetes cluster. So let's see, other interesting things to talk about in this dashboard real quick. Oh, in the services section, we can see that I've got one of them. It's load balancing across it. We have 2 servers behind it. And we can see the IP addresses here as well, similar to what we saw in the Docker swarm world earlier. And then we can set other flags and things, and we can even see where it's used. So we can see, okay, what routing to this service? Maybe you've got some really complex routing rules. You can come in here and take a look at all of it. So that's kind of what an ingress does. It's very similar, and it's very declarative, kind of like that Docker swarm model, where we can just say, here's what I want my traffic to look like. Here's how it needs to be routed around the cluster. We talked a little bit earlier too about other provider things that we can talk to. It can also talk to console, Amazon's ECS, Marathon, Rancher 1.0, Rancher 2. Anything is just, or it runs on top of Kubernetes as well. So it's going to use your normal ingress type objects. Traefik, well, touch on this very briefly. So we have this ingress object. As you might imagine, this is kind of the generic that's used by all of the Kubernetes things that are out there that use ingress objects, but different ingress controllers like Traefik have kind of their own, I don't want to say above and beyond, but it's one that it doesn't quite match that lowest common denominator. So they've created other objects that look like an ingress object where you can do more specific configurations and you can make things look like, I'm going to jump back to Michael's slide from earlier. So when you write these rules and this rules language that Michael sent us, this link in here when we have all these available rules where we can plug those in generically. And that's where we can do really crazy things like regex and weird path modifications and matching and all kinds of other fun stuff. So there is another type of ingress thing, but this is kind of the base definition of how everything fits together. Looks like we have a question. The ingress definition doesn't specify which service endpoint to use. How does it know which pod services in that namespace to use? So down here at the bottom, we're matching this path, and we're going to tell it the backend service, and the service name is who am I, and the port is HTTP. If we so that is kind of it does bring up an interesting point though. So within Kubernetes, we noticed earlier when I was talking about the deployment, there wasn't a reference to it. There is another object in Kubernetes called a service. So Peter, you didn't miss anything. I just kind of skipped over a part of it that's kind of behind the scenes, where the service is creating, we're selecting apps that match who am I, and we're saying port 80, and we're kind of doing this, we're mapping port 80 to another port 80. And this is kind of that internal load balancer thing where maybe you'd skip that ingress. It's kind of out of the scope of this, but it is something that needs to kind of be noticed. If you're doing things like sticky sessions or persistent sessions, like I was talking about earlier, where maybe container A knows who you are, but not container B, you would apply those types of changes on the service itself, not at the traffic layer. So when you get into Kubernetes, I know we all like to joke that there's really no problem in any of our jobs that can't be solved with like more layers of abstraction. And in this case, we're just adding yet another layer of abstraction to all of this. So we have services can be like internal load balancers, or if you're running in a cloud, you can even create a service and say, hey, go create a load balancer for me, and it'll go and do that. So, and it can, the service stuff in Kubernetes, so you mentioned in the group that it's the Kubernetes VXLAN type thing. Yeah, you mentioned that it's just one option to create the network. In Kubernetes, there's networking, again, is probably a multi-day talk for Kubernetes, and it just goes more layers of abstraction and plugins and extensibility and interfaces and all kinds of crazy stuff. So we definitely won't get into a whole lot of those details today, but it is something to know that there's that other layer of abstraction that's living in there. So this is kind of the boring part, I think, of traffic, in that it routes traffic. It's boring in a good way. And I know one of the big pieces that everybody likes to talk about is TLS management and its nice integration with Let's Encrypt and other services. So Michael's done a whole lot more work with that than I have. So I'm going to throw it back over to him for a demo on that.
Hurrah. Lots of good questions too. This has been awesome so far. So I did just want to bring this up real quick since it just came up again. This is the page that has that I linked to and referenced earlier, that has a bunch of the different routing rules and all that kind of stuff. And so, for example, you can route based on headers in the request, or host, or the host header. If for whatever reason that's different, it should never be different. But a method. There's lots of different ways that you can set this up. And as we kind of saw in the example, or in the dashboard that Phil had up for a second, that you can do ands and that kind of stuff. So you can make some pretty sophisticated rules as well. And one other thing I'll just mention too is, Phil was talking about services, and yeah, that's an abstraction layer. And like Docker, for example, that's, you really have no control over that abstraction layer. But with Kubernetes, there's a lot of other extensibility options. And so, for example, in some environments, you may take those service definitions or the service objects, and maybe instead of doing all that routing internal to the cluster with, virtual routing or virtual networking, you can actually take that and pull it out into AWS land, for example. And there's a lot of really neat networking things that you can do there, but it does get pretty complicated. And finally, one last thing I'll just mention too, kind of plugging in the RBAC mechanisms. The ingress objects here, letting them be separate ingress objects rather than labels on a container, makes it much, much easier to do like multi-tenant Kubernetes, where it's really, really hard to do multi-tenant swarm clusters. And that's because you could, a variety of different things. You could say, hey, whoever's running the cluster defines these ingress objects, and they own the host names. But also Kubernetes has some really neat capabilities called emissions webhook controllers, which again, we're not going to get too much into, but it could say, when you apply this ingress, let's evaluate the policy and find out, can you actually, are you in this namespace authorized to use whoami.localhost? And so, like, for example, at Virginia Tech, we're doing exactly this with some multi-tenant Kubernetes clusters, in which we'll annotate a namespace and say, any application in this namespace can use domains X, Y, and Z. And so if they try to define an ingress that uses domain A, it'll say, hey, that's against the policy, and will deny the ability for that ingress to be deployed. And so Kubernetes provides a lot more RBAC mechanisms, but also policy enforcement, where Swarm doesn't. And so that, again, we can spend a whole extra talk in there, but there's a lot of really neat stuff, and it's let us build some pretty neat clusters and environments for people to use. All right, so let's talk TLS management. First off, why?
Michael, yep. I want to jump in real quick and talk to Peter's. He mentions that service networks in Kubernetes are global. They are global. You can add some security to that with network policies as well. So you can do some really kind of crazy rule cases in there where it, let's solve the problem with yet another layer of abstraction, another rules thing in there, and more YAML. So it's powerful, but yeah, there are some ways to control that a little bit.
So, and I'd say in that space, actually, we're doing something exactly like that, in which, so all of our namespaces, we've got annotated with who owns that namespace. Is it part of like platform services, or is it a tenant namespace? And so network policies, we've got policies in place that traffic can't go from one tenant namespace to another tenant namespace. They can't cross namespaces, but they can go from like the platform services, like our Prometheus monitoring and metrics, or even traffic itself, that they obviously have to go cross namespace. But so that there are some ways to lock that down too. And it also depends on what network CNI driver you're using, all that stuff too. So again, that gets pretty complicated pretty quickly. And then there's another question here. Does each pod have their own individual ingress controller, or is the ingress controller acting as a load balancer in between services? And so actually, let's go back to the picture here. So it works pretty much exactly like this, where the ingress controller, at the end of the day, a controller is really just another container, another pod that might have a little bit elevated permissions to watch for state changes in a cluster. But there's no designation that says thou art a controller. It's really just, it's watching state changes. And so Traefik is just running as a container, and it's querying the API server and responding to the network changes. So is there one of these, or are there many of them? It really just depends on the needs of the cluster. For a lot of clusters, if you're not running a lot of heavy workloads, you may be able to get away with just a single Traefik instance. But you can run multiple replicas and they'll all watch for state change. But it's definitely not a one-to-one mapping of Traefik to backend service there. And Peter said service definitions are the pod network balancer. The ingress role is mainly to understand which service to route incoming requests to, although as you can see, you can add other features to it. And that's exactly right. We typically deploy at least 2 ingress controllers per cluster. And yeah, so there's lots of different deployment architectures that you can utilize. As Phil mentioned earlier, there are some groups that may use a combination of Traefik and Nginx, or even different types of controllers. Personally, I've never had a reason to do that, but you certainly can. Typically, we've been able to do everything with just Traefik, and then we scale up or down how many replicas of that, depending on just how much traffic. If you say traffic too many times, it's hard to know which traffic you're talking, but how much HTTP, how much network, how many requests we've got coming and going. And again, something else that you can do with Kubernetes as well is you can have different kind of node pools. And so you can have a set of worker nodes that's just for ingress, and maybe has extra network, like in the cloud, network optimized machines, and run just the ingress on those. And so yeah, target traffic to run just on those nodes, but then all the other nodes are in a separate node pool. It's also one cluster, but then you can make sure that your ingress have dedicated machines with higher network throughput or that kind of stuff. There's a lot of really different things you can do. So big reason, internal, external exposure differentiation or high traffic pods may require specific isolated ingress so the rest of the cluster doesn't suffer. Sure. Okay. Yeah. Good points there. All right, let's talk TLS. So first off, why HTTPS? And I know TLS isn't just for HTTP based stuff, but we're going to talk HTTP anyway. So the HTTP protocol is a stateless protocol, and that means every request that comes to a server, the server is basically like, who are you? And has no idea who you are. There's no pre-assumptions that come along with, hey, this came from this IP address, and the last time I talked to that IP address, we were at this state, so let's continue that state. There's none of that. And so to fix this, web servers and HTTP supports what are called cookies. And cookies at the end of the day are just a header that is included in the request, so that when a server starts an initiation with a user, it says, hey, here's a cookie, put it in your cookie jar, and the next time you come back to me, bring the cookie back, please. And so then the server says, hey, I see this unique identifier in this cookie, and so therefore I know it was issued as part of this request, and let's look up all the state, all the session that was associated with that user. And so that at the end of the day is what cookies are. And I'm pretty sure all of you already know that as well. But this last bullet point, the cookies need to be protected. Session hijacking is real. It's so true. Man, I made a YouTube video, man, it's probably 10, 11 years ago at this point. There was a new extension made for Firefox in which it was called Firesheep, in which you could basically sit there and it would put your Wi-Fi card in promiscuous mode and just listen to traffic. And any port 80 traffic that it saw, it would steal the session cookie out of it and basically put it in a menu. And if it was like Google or Facebook or Twitter, like some of the big names, you can just click on the menu icon and it now set up your browser to have that cookie, and you became that person. And so I made a little YouTube video showing it off and everything. And in many ways, I think that extension is what really increased the awareness of, oh crap, we've got a problem here of everything's using port 80. That was before, it was HTTPS everything, and everybody was worried about the overhead and CPU for encrypting all the traffic and all that kind of stuff. So, but that really forced the issue. Hey, if Joe Schmo can just download this extension and sit on the Starbucks Wi-Fi, which might or might not have been encrypted at the time, and now they can become me. Oh my goodness, this is a big deal here. So HTTPS solves that problem because now that part is part of the encrypted payload, and can't be stolen just by sniffing traffic on the Wi-Fi. So how do we do this? I'm sure many of you have gone through certificate provisioning and know how hard and ugly one it used to be, but also for some of you it may still be. So be careful with my words there. But you had to go to a certificate issuer and kind of prove your identity, and there was this back and forth and forms to fill out and all this stuff. Is a very manual process. And so Let's Encrypt started back in 2016 to figure out how can we do this for free, but also scale it and automate it. And what they did is they basically built the Acme protocol. And this protocol provides a way to say, hey, I want a certificate. And before they sign the certificate, they'll say, well, prove that you have ownership over the domain that you're requesting a certificate for. So they give you a challenge. And then when you complete the challenge, they'll verify that you met the challenge. And then if everything's good, cool, they'll issue the signed certificate. So an example looks something like this. Web server admin software says, hey, I want a certificate. Please sign this for me. And it says, okay, cool. Here's a challenge. Put ED98 at 8303. Now, obviously this has been shortened just for the graphic, and the real versions would be much, much longer. But what they're saying is, hey, put this random identifier at this random location on your web server. And so then the server software would either put it at that location or update routing rules so that it would work. And then it will say, okay, I've got that ready. And Let's Encrypt will say, cool, let me fetch the file and make sure it's there. So one, this is validating that DNS points to the server, which again is proving that you have ownership over the domain. And then we'll check that file and then make sure that the contents match what the challenge expected it to be. And this is one form of verification. There are other forms using DNS where Let's Encrypt will say, hey, maybe you can't do the web server one because it's a offline server, air gapped, or security rules make it so we can't do an HTTP request. So to prove ownership, if you've got ownership over DNS, well, you've got ownership over the domain as well. Or at least the web server that it will be running on. So create a DNS record that has this value at this record. And so you can do challenges that way. And there's a third method that I'll let Phil mention in just a few minutes as well too. But anyways, it's this idea of, hey, I want a certificate. Cool. Here's a challenge. I meet the challenge, and then a certificate is issued for me. And again, this is all part of the Acme protocol. There's lots of vendors that implement this protocol now. Let's Encrypt is just the biggest one, and they're the one that basically built the protocol from the start. Okay. So that's great. How do we make use of this? Traefik has built-in support for Let's Encrypt, and will automatically do everything that's needed. So it automatically requests the certs for desired host names. I can say I want to cert for hostname X, and it will start the communication with Let's Encrypt, or any other Acme provider as well. It can validate the challenges, and it knows how to do the HTTP one, and it can support many of the DNS providers. If you're using some of the biggest ones like Cloudflare or Route 53, or there's a large list. If you use any of those, it's got integrations to be able to automatically put in DNS records for you as well, assuming you give it credentials to do so. And then the other big advantage here is Traefik will handle the rotation of the certificates. So I think Let's Encrypt certs right now, if I remember right, are 90 days, but I know that they've talked about shortening them to potentially even down to 30 days. So they're pretty tight. And if you're doing that manually, that's a lot of just rotation. But Traefik manages all that for you, and it's completely behind the scenes, and you don't have to worry about it, think about it, etc. So how do we configure Traefik to do this? Again, I'm doing this with command line args. Phil mentioned earlier that you can do all this through a config file as well. And I think I've seen in chat an example of somebody that was accidentally putting it here, but of using a toml-based approach. So there's lots of different ways to configure Traefik. So in this case, I'm going to run swarm mode. I'm setting the default network that it's going to use. And what we see here is I'm setting up entry points, which are the ports that Traefik is going to listen on, and some of the rules around it. So this first one, I'm naming web, and it's going to be on port 80. And what I'm doing is I'm setting up an automatic redirect so that all requests to it are going to redirect to another entry point called web secure. And the scheme for that is HTTPS. Okay. So basically this is setting up automatic port 80 to 443 redirects, and my downstream apps don't have to do that nor worry about it. So for the web secure entry point, I'm saying I'm going to do this on 443. It's going to be using TLS, and it's going to use a cert resolver called LE resolver. So Let's Encrypt's resolver. We set up the dashboard. I'll mention this real quick. This insecure skip verify, it's not part of the Let's Encrypt stuff. But going back to what we were talking about earlier, the leg between Traefik and the backend app, if the backend app is using a self-signed cert, this is basically saying, hey, don't verify the certificate. Don't worry about it. Just let it go, kind of thing. So then that communication can be encrypted, but it's not necessarily trusted. So that's what that flag is. Then the last three here are actually setting up the Let's Encrypt resolver. So certificate resolver, I just name it LE resolver.acme. I'm going to use the TLS challenge, which is the HTTP based one that we were just looking at. Use it to true. In order to do Acme, you have to give it an email so that it can send certificate expiration warnings, or if there's ever any other details. I've never once gotten a spam notice from them, so it's pretty good there. What email address to use there, and then storage is where is it going to store the private keys and whatnot. So I'm just going to store that in a file at /acme.json, and you'll see that I also just mount that onto the file system as well. So if I have to restart Traefik or whatever, I don't have to reissue all my, start with brand new private keys, reissue certs, all that stuff. It persists longer than the life of the container. So what I'm going to do here is we'll show this slide real quick, and then we'll do a quick demo. And I use this for my home lab setup pretty much, in which I've got, my home router, I've got port forwarding rules going to just a machine that I have sitting here at home. And in this case, it's actually a swarm cluster. It's just a swarm of one, just that one machine. And it's running Traefik on it with Let's Encrypt. And so I can put a DNS name on it, and even a wildcard on that name to point to the router here. Let's see, did I close that tab? I did. So in this case, I'm actually using Cloudflare. I guess it logged me out, so never mind. I won't log back in. But what I'm I'm going to ask you guys in chat to send just a random subdomain name, and we're going to use that name for the little cats app demo that we've been doing. So whoever's first to put a subdomain name in chat, we'll use it. Foster. Okay. Foster cats. I see where you're going there. So I've got a DNS, both a main name and the wildcard pointing to my home IP address, which then we'll send it to Traefik, and then we'll go from there. Okay. So let's actually do that real quick. So I'm on my node here, and we saw somebody wanted Foster. And so I've got this domain name, Mike's37.training, that I use for a lot of my workshops or whatnot. And so I pointed Novolog and the wildcard to my home IP address. So please don't DOS me while I'm doing this, but let's go ahead and, so I'll do a Docker stack deploy, and we'll call this Novolog. Oops. I didn't remove one config piece there. All right, and so this is deploying the that service. And so we see that it started up, and if I open up, so foster.novolog.mike37.training. Okay, so right now it's still going through that process. So I'm getting a certificate authority invalid because, let's see, if I open up the certificate, it's in the security tab now, view the certificate, it's just using a Traefik default cert. So by default, it just uses it's an unknown CA, it's a self-signed cert because it hasn't finished going through the Acme protocol, okay? And now if I refresh this, okay, now it's happy. I've got a page is secure, page is valid, and I see that the certificate has been issued. R3 is the Let's Encrypt issuer, and it's trusted by my browser, and we're good to go. So it just takes a little bit to go through to get it to go through that process. And Peter said he's still seeing it self-signed from here. I've noticed sometimes the browser does that, so maybe try an incognito window, and maybe you're doing it with curl. Well, oh, it's Foster, not faster. It's Foster, not faster. So yeah, so in any of the domain names that I'm not actually serving, it's still going to use the self-signed cert until I've got an app that it's actually trying to use that endpoint there. So and yeah, so with that, I got a free TLS cert and went from there.
And I'm going to jump in real quick too.
Yep.
So in this case, it was using the TLS challenge, which if you're doing this at home, so for me at home, my ISP, I have Cox, they block port 80 at home. So one of the nice things with the TLS challenge, it's not supported by a lot of the standard Let's Encrypt agents, like I think CertBot and some of those. It handshakes a little bit differently. So you can they'll validate your cert and sign it with only port 443 open, which Cox does allow. So depending on your ISP, if you're trying to set up a home lab for something like this, Traefik in some respects is easier than some of the traditional stuff where port 80 is closed. So just something to kind of keep in mind as you play with it.
Yay for home ISPs. So, and actually, that's a good point too. I have in my config that I'm using the TLS challenge. It might actually be that when Let's Encrypt is going through here, it's using 443. I'm not actually, I'll have to check which route it's actually doing there. But anyways, so yeah, this makes it really nice to be able to do home setup stuff. So if I'm doing any sort of a, demo, or I want to show something off, or just run an app for, my own use or whatever, I just add the labels to it, spin up the container, and not only is Traefik going to start routing to it, but it's automatically going to get a TLS certificate and go from there. Now, one of the things to note too, if you go this route, Let's Encrypt participates in and I forget the full name of it, but certificate transparency reports or whatever. So I could actually, I don't know how quickly it shows up, but all of the domain names that I request, or all the certs that I request, are part of a public list. And so yes, technically it's at home and I'm probably not going to link to it or, all that kind of stuff. I'm not going to share it with the world, but folks will be able to see, I just requested a certificate for foster.novalog.microservice7.training. So if you're trying to do this and want to keep things kind of quiet or kind of secret, that kind of stuff, Let's Encrypt may not be the right issuer that you want to use there. So just a heads up there. I do just want to mention, since we talked Kubernetes a little bit earlier, certificate management in Kubernetes, you can certainly use Traefik, but a lot of times people don't use Traefik in Kubernetes because they also have other certificate needs. And so what they'll use is a tool called Cert Manager. And Cert Manager is another component that's deployed to Kubernetes, and it makes use of what Kubernetes, its extensibility. So within Kubernetes, you can define what are called CRDs, which are custom resource definitions, and allows you to define other types of objects. And so, yeah, the native Kubernetes has no idea what this object is and nothing's going to respond to it. But what CRDs allow me to do is I can define a new type of object, and then I can also run another controller that's watching that type of object and responding to it. So it allows you to extend the event-driven system that comes along with Kubernetes. And Cert Manager does exactly this, and we'll see an example of it here in just a second. What's nice about Cert Manager is it allows, it does this certificate provisioning process, and it can work with many providers. So it can do Acme, Let's Encrypt, Sectigo, all that kind of stuff. It can also manage a self-signed or local CA. So if I wanted from Traefik to all my apps to actually be encrypted, I can issue certificates from Cert Manager to each of my backend apps that are issued by a CA being run in the Kubernetes cluster. And so then I could configure Traefik to say, hey, trust the internal CA. And so then I can still have trust between the applications. So there's some pretty neat stuff you can do there as well. And then what happens is when when Cert Manager issues the certificates, it stores the keys and the cert and Kubernetes secrets, where then other things can pick up, like Traefik. So an example of this, I can define a cluster issuer, kind of just like the certificate resolver, similar concept with Traefik. I can say I'm going to define an issuer here in which it's going to use Acme. Here's the server endpoint. Here's where to store the private key for the account that it creates with Acme, and just some other details about HTTP resolving. Once this cluster issuer exists, then myself as maybe an applications team, I can say I'm going to deploy an application. So I'm going to go back to Phil's example earlier. I'm going to create an ingress object, but I want that ingress to be encrypted. So I'm also going to create a certificate. And that certificate, I'm going to name it. I'm going to use the Let's Encrypt issuer, and I want the common name and DNS names to have myapp.example.com. All right. And when you're done with it, I'll store the key and the certificate in a Kubernetes secret called myappcert. Okay. And so what's going to happen is I declare and I apply these manifests, and Cert Manager, which would then be running in a cluster, will see these objects get created, and will say, oh, cool, I see the certificate object. Let me start the Acme protocol. And once I'm done here, then it stores the details in the secret. And then what that allows me to do is I can go back to my ingress, and I can specify this TLS section at the bottom and say, all right, here for this host, here's the secret name to use. And Traefik, again, since this is ingress, this ingress object is a standardized object. Traefik is already consuming the rest of it, will also consume the TLS portion of it as well. And I know this chart may or may not make sense or whatever, but as the request comes in the Traefik for myapp.example.com, it sees it and says, cool, that means I need to do TLS termination using the credentials that are in the secret. And so it does the TLS termination back and forth with the client there, and then we'll send the request on to my app. So it's kind of hard to draw the full flow without it being without it being, just a sequence diagram. But anyways, Cert Manager makes that a lot easier. And so then Traefik in most environments, rather than Traefik being the one that's doing the Let's Encrypt, mechanisms, you use something like this, and then Traefik just picks up the certs and uses it from there. So I don't have an example of that to try out, but it's pretty straightforward here. So, and with that, I will hand it back to Phil. Any other questions or whatnot? Okay, I haven't seen anything else come. And we're almost done, don't worry. I know it's almost noon.
Yeah, I was going to say, I know we're getting close to time, so I'll try and make this part relatively quick. So I guess the one last thing in my mind that Traefik we still haven't covered is traditional, whether it's a reverse proxy or load balancer, typically offers the ability to modify the traffic kind of before it sends it onto that backend. So one of the things that you might want to do is maybe you have an IP like waitlist, allow list that you want to do to limit access. And you're just trusting Traefik to reliably do that. Maybe you want to add HD basic auth. Maybe you need to modify the request, add a header, remove a header, whatever. So one quick example that we can do is we can create this middleware. In this case, this matches something that we're using at Lynn & Mary, where we have an API that we've written where we can say openapi.it, and we're going to do a get of /API/v1/courses/department, computer science, in this case, 301. But our application on the back end is expecting just /department name/course number. That way our developers, in this case, don't have to worry about, what other APIs are there, or, and this kind of gets in that microservice design pattern where we can have our group that works on the course API doesn't necessarily need to know that there's also a people API or a, events API and a calendar API and all these other things that might exist. All they really need to think about is, I'm writing courses, so what do I want mine to look like? So then we write this kind of crazy middleware thing with regexes, everybody's most favorite thing to deal with. So in this case, we've written it pretty simple. We have API/v something. We don't really care what it is. And then whatever the next word is, we're just going to, in this case, the type of this middleware is called a strip prefix regex, where anything that matches this, we're just going to rip off the request before we pass it on to the backend. So this incoming request from the front end ends up looking like what we expect on the back end. So Traefik kind of modifies that while it's in flight. Your applications have to know about it. This isn't something you would necessarily want to do super widely, especially for like things where relative paths are expected and stuff, because it can make weird things. But for APIs, these middlewares are really, really kind of slick, and you can do a lot of neat things with it. So this is just one example of how we use it. And then there's some other crazy syntax. For interest of time, we'll skip over it, but where you attach this middleware to an ingress object, or you can attach multiples. So maybe I want to take one of these and say, this is only allowed from within our campus network, but also I want to modify the path on its way in. So you can chain these different things together. And the reason this is written in a regex is we can reuse this across multiple things. So if this was the events API, we could reuse the same type of thing across multiple implementations of it. So there's a bunch of these built-in ones. They also have this new feature that's, I think it was released in 2.4. It's relatively new. It's still kind of, I think, labeled beta and experimental, but there's a way to write your own custom middleware things. It's all in Go. It requires integration with this cloud monitoring tool called Pilot that Traefik uses. There's actually some really cool stuff out there. If you have a chance, you might want to go to that website at some point and look at all the plugins. They have some really cool ones with Swarm that will, like, you can essentially stop a service, and when the first request comes in, Traefik will talk back to Swarm and start it up, and you can really kind of do some kind of really interesting things that definitely wouldn't normally be in the base piece of Traefik as a reverse proxy that does service discovery, but it is really useful for things that maybe you want to add some extra coolness to it that maybe doesn't belong in the root tree. So that's something that's kind of fun that they're working on. Other notable features in Traefik, I'm just going to run through real quick. Obviously, is sticky and persistent sessions. You can do tracing, where if you've got some really complicated call of, service A calls service B that calls service C, and you don't know which one was slow, it can kind of help you check that stuff out using some of these other popular upstream tools that are out there. There's a number of them. It can do metrics collection. I can show a quick example of that if there's interest. It's something we do internally, where we use Prometheus, and we can just look at, for every particular backend, what's our request rate look like? What response codes are we sending back? That way we can do some quick metrics, and how long is it taking? So we can kind of just do a quick overview of what's traffic handling for us. I listed it as a feature, JSON logging, so you can machine parse it. Personally, like having something that's machine readable is nice. Luckily, the Apache standard is fairly easily parsed, and the Nginx thing is fairly common as well. But with JSON, I don't have to worry about if they add a key and things like that. So that's something we also turn on. So I'm happy to dive into some of these. I know we're at time, so I don't want to just jump right into it. But for that, I guess we'll kind of kick it over to questions. Our contact information is there. If you think of something later, you want to yell at us that we're wrong, whatever it might be, putting something on the internet. And also too, our Twitter accounts are there. I think both of us are, most of our tweet stuff is related to the stuff, though with mine, you're going to find a lot of motorsports and Virginia Tech things because I went to school there. So I'm still an athletics fan in a big way. But our contact info is there if you want to yell at us, follow us, whatever. And if you'd like to see demos of some of that other stuff, we can kind of pull up our internal. I'm happy to pull up the William & Mary like consoles and things, and we can look at it in a more enterprise environment if people want to.
Yeah, and I can show off some. We've got a pretty neat QA environment that does some of what Phil was just talking about with, we've got lots of feature branch based deployments, and if a specific deployment doesn't get access over maybe a 30-minute period, it automatically scales it down so that nobody can, we're not paying for it. But then the first time somebody tries to access it, we go to this launcher page and spin it back up, and Traefik's a pretty integral piece to that too. So there's a lot of really neat things that we can do there. A question just came in. Do you utilize K3S in your cluster? So I don't use K3S in my, we're not using it in our production clusters in AWS or, for Virginia Tech, but, well, I can't pull it over, but like I've got actually a Raspberry Pi cluster here. This one's just not plugged in right now. I've got another one that is plugged in, and especially for like ARM or, small IoT kind of stuff like that, I'm definitely using K3S because it's a much lighter weight orchestration framework there. It's basically Kubernetes, but it's just stripped down a lot. That's why they shorten it from K8S to K3S. 3 is less than 8. It's just stripped down. So, but yeah, I use Traefik ingress on that as well too. And I guess with that,
just for completeness, my answer is the same as Michael's. We don't use it at William & Mary, but at home I use it on Raspberry Pis and things like that too.
All right, and with that, since if there are any more questions, you've got like 10-15 seconds to get them in. Otherwise, I'm going to go ahead and stop the recording. So
One in chat.
I'm looking. Well, I saw that, but that'll be after I turn off this.